Okay, 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 okay. Should we go ahead? Will it not cross 50? Okay, anyways, maybe we will have water break. So this is where I was, right? Okay, and I was trying to tell you data quality is very important, right? Otherwise, there's no meaning of all this fancy technology, right? Data quality does matter, right? Okay, and it is really important. Now, in this session, the last thing that I want to tell you is that this pyramid is very, very important. And probably this is the only takeaway that you can have from this entire workshop, right? Okay. Why all are we doing this, right? Why there is a whole lot of technology coming in like GPT-3, right? And so on and so forth, right? So the only thing is that we are trying to, get the wisdom, right? And once you have these all sorts of things to support your decision, right? Probably you are going to, make a very good decision, right? Okay, so the whole idea is this pyramid. Data will lead to the information and of course wisdom and all, right? Okay, so this is very much self-explanatory, and then I'll be going ahead. Yes, we crossed 50, right? So here it is. Last takeaway. Right, so you will find in your organization, and these days I'm sure you must be very with words like data driven, but you have to really mean it through this set of framework, right? You have to really create a culture of data driven decision, right? You will surprised to know, once in my college canteen, in college canteen people used to do the canteen wala used to make a no what you call it, manual billing. Paisa leta tha aur saman deta tha. So I said, hey, why don't you record all this now? I can tell you how many people are buying chai with samosa. You can have a data driven strategy. You can start recording this data. You can have computerized billing and all. And he was killing, sir, nahi do aap. I'm sorry for that. So we'll moving to the next session, right? Okay, if you have any other question, meanwhile you can put into the chat box. So now we are almost, I think, the one more topic that we have. Yes, yes, in continuation of that. And okay, 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 so let me share the screen. Okay. Is my screen visible, ma'am?
Sir, it is now visible, yes.
Okay, perfect, perfect, perfect. Okay, okay, good, good. Okay, so are you still excited? I am. Okay, okay, so here is an activity. Just have a look and what do you think? What I'm going to talk about next. Maybe in chat box. Maybe in chat box you can put what I'm going to talk next. Right? Anyone there? Okay.
Uh, Ria says, I'm thinking. Guys, let us know in the chat box. Ritik says report. Rahul says hypothesis. Prabhu
Uh,
says hypothesis
okay.
testing. Vaishnavi process.
Okay, 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 okay. That's good, good guesses. But trust me, I'm not going to talk about hypotheses because these are the traditional topic that you know a lot. I have focused more where there that is new to you, right? Okay. So basically, of course, these all are the what you call it situation you go through in your data science journey, right? You have observation, you have questioning, endless question, hypothesis, experiment, and so on and so forth, right? Okay, so let's go. I'm going to talk about the experiment, right? Okay, that is my favorite part, right? That is why you're okay. I will not say what you're going to call, right? So what is experiment? You remember first science class? A systematic, rigorous approach to problem solving that applies principle and technique at data collection stage, so to ensure the generation of valid, defensible, and supportable conclusion, right? Guys, I'm not sure whether you have bothered about it looking at this or not, but all there is a lot of fad around this in data sciences, machine learning, all that, but nobody is able to explain why certain things are happening. Machine learning is now called black box, right? Not now, earlier also. There's no explainability, right? Let's say I made a machine learning model, somebody got loan, somebody didn't got. In India, it is a no problem, but in US, it is a big problem. There's a right. How can you deny the right? And if you can't explain why certain people didn't get because you got machine learning, you can be sued, right? So the idea is whatever we are trying to do, it should be explainable, right? You can see it should be verifiable, right? supportable conclusion, right, through data. So that is why you have to design your experiments in a nice way, right? Okay, okay, okay. And so what? So in this particular session, I'm going to talk about that only, right? Okay. Okay. So what is the steps in experiment? Very simple. I'm sure you all of you remember your school days. That very first thing is that we have define the problem, right? You have to spend a lot of time in defining the problem, right? Okay, right. We do not rush, right? This will be your first and foremost step. You should not use what you call it atomic bomb to kill ants. Same with the data science problem, which can be solved with other technique. You can solve with the data with a normal technique. You should not apply data sciences only, right? We should not think, okay, everything can be done by data science, right? So defining the problem very quickly, right? So let's say there is an agriculture company and they want to develop a new line of crops that performs better in a wider range of condition, like in different kinds of condition. So what question they are going to ask? What is the experiment hoping to achieve? What insights? Are we being too bold or too broad or preventing us from drawing an insight? Right? I mean, you have to very balanced question. That is very, very important. Okay. Right. Then choosing a measure. That means how we are going to collect the effectiveness of the experiment, right? Okay. Determine what the correct metric for collecting data, right? And all sorts of things. These all are the very little self-explanatory thing, but you have to keep in mind the bigger thing. What you are going to measure it, how you are going to measure it, right? Okay. What factors are you going to take into the consideration? Are we taking enough factor, right? Have we considered everything, or there is something else that is left out, right? So you have to spend a lot of time determining the potential source of influences on measurement, right? Okay. Then you have to design an experiment, right? And there's one very particular takeaway for you is here is a confounding variable, which you might find somewhere, right? A variable that influences both independent and dependent variable. Very, very important, right? Confounding variable, a variable that influences both, right? Okay. Create a spurious relationship. That means there will be no relationship, false relationship you will see, right? Okay. So it sometimes might happen. So you have to, when you are designing experiment, you have to be very, very careful about, right? Okay, all sorts of things. Then of course data collection. This is where you have to spend again a lot of time. What is the right strategy to collecting the data, whether it is going to affect the data quality, right? Whether we are going to get a data on time, and so on and so forth, right? Okay. Then, so in short, if you are trying to design an experiment, right? Self-explanatory. Define a problem, very clear goal. It should not be ambiguous, right? That means you should clear what you are trying to solve, right? Like the retail company, right? Then you have to select the measures, brainstorm factors. That is why it is a teamwork. You can look at all the possible factors, and then you should have a plan. And finally, you should interpret your result very nicely, right? You should be able to tell people why certain things is happening. Very, very important, right? Otherwise, there's no point in having fancy visualization, right? If you're not able to interpret your result and conclude in a proper context. Okay. So the takeaway term for you will be here randomization, so that there is a reduced bias, right? Then you can block, right? Okay. And of course, the factors there are there which can influence, right? Like confounding variables. So only thing to remember is that a very important thing where I will spend most time here is take your time. Rushing steps create problems. Do not rush कि मुझे आज कल सुबह तक ही project करना है. No, it is not like that. If you do not have a relevant data, first collect the relevant data, right? Try to get all the right strategy, right? Okay. And otherwise it will become very harder, right? Revisit each step briefly as you continue. Ensure changes you made along the way. That means there should be iterative process. If you feel something need to be modified, something need to be also taken into care, and so on and so forth, right? Okay. And last but not least, that is why you are called data scientist, right? And trust me, it is data scientist also fails a lot. There are only 7 8 algorithms that is highly used in industry. But if you ask for a given problem, okay, should I go with this particular algorithm? Nobody will tell you. Even 10 or 15-year experience, even an experienced data scientist is supposed to fail. They also heat and trial method, right? They also trial and error method apply, right? Okay. And so on and so forth, right? So because until unless you do not try, right, you don't know, right? So that is why data scientist, it looks fancy, but a lot of hard work, right? Okay, and you will have nightmares also sometime. Okay, so that was some wisdom around, being a data scientist. Okay, and last I have the last slide, last session I have, right? Okay, and then floor will be open for the discussion. Okay, maybe some books and URLs that you want to have it, or some interaction, right? So that we can find it up. Okay, please just give me a minute. Okay. Okay, sure. Resources to boost fundamental. Definitely. I'll talk about that. So, in fact, that is what our last session is all about. Okay. Okay. I have purposefully skipped something so that we can have more time for interaction, because I believe that is more valuable for participants. So let me share my screen. Yeah. So, yesterday we have seen. Is my screen visible to everyone? Is my screen visible, ma'am?
Yes, sir,
Okay.
your screen is
Okay.
visible.
Perfect. Okay. So, okay. So, now I'm going to talk about little bit advanced decision tree, but I will not talk about this machine learning part, but very simple approach, right? What is a machine learning? Where, you do not explicitly program it, right? Okay. Right. So, I'm supposed to talk about a decision tree, right? How many of you think that there is a tree which will give you a decision, right? Yes, of course, decision tree is like that only, right? It falls into the category of supervised learning algorithm. It is a very huge slide. I will not go into each and everything, but I'll take a case study and probably I'll discuss that with you, right? So basically, you can think of a decision tree is like, let me just skip this part, all mathematical jargons. You can think of decision tree as a tree, right? Which can help you, which can help you to take a decision. Do you know where is the famous tree in India? Right? It is in Bodh Gaya, where the Gautam Buddha got enlightenment, right? It is. I was fortunate enough to see that tree, right? So I think tree has to do something with the science. What Newton was sitting around, that tree, na? That apple fell down or something like that, right? Okay, fine. Anyways, we don't have to worry about that because the question is already established now. So there is a decision tree, right? And what is the basic idea about is like it will help us to get something out of the data, right? Let me take you forward, right? So I'll take you this example, very simple example. Here it is. Just look at this data, right? Okay, so if you look at this data, right? Okay, we have a patient ID, we have an age of a patient, we have a sex, that is whether somebody is male or female. We have BP, means blood pressure, cholesterol, and drug, right? So if you look at this cholesterol, BP, sex, age, and patent ID is a dependent variable, independent variable, and the drug is a dependent variable. Based on this particular phenomena, we are going to recommend A, B, C, or whatever A, B drug to the particular patient, right? And you can see that there is a patient 15. For that, we don't know what drug should be. This is what we are going to predict using a decision tree, right? Okay. So how do we do that, right? We'll go very quickly in these steps, right? So basically, all the drugs are there, and we have to predict for the patient 15, right? So what actually you do is, what is the meaning of modeling? You know, uh, Modeling means data plus algorithm, right? You can see all the data plus algorithm, and then finally you get a predictive modeling, right? Okay. So we are going to apply all sorts of things, and we are going to predict drug for the patient 15. Okay. And especially we are going to use decision tree here, right? So you can look here, right? In decision tree, actually, you can see if there is an age, there is a further distribution, young age, middle age. After the age also there is a sex, right? Whether it is a male or female. Then accordingly we are giving the medicine, right? Whether the drug A should be there or drug B should be there. If it is a senior, if it is a senior age patient, then cholesterol we need to check whether it is a high or normal, right? In case of high, we'll give drug A. In case of normal, we'll give drug B. But in case of middle age, there is no further check. That means what? In decision tree, these all are called nodes, right? And we try to split the data, right? And the final, this is called the final that you see is it is a decision node, right? Okay, okay. These are some jargons again. So how do you decide? How do you decide that which? You can see this is called age is a root node here, right? Root node. Data a root node, right? So how do you decide which features to take as a root node, right? That is very important in decision tree, right? So how we do that, right? Okay. So let me go ahead, right? Okay. Again, these all are the very simple things. So the key point is that we have to test an attribute. Attribute means features, all that patient ID, blah blah, age, and all that, right? So testing an attribute and branching the cases. That's what you need to remember in the decision tree. Testing an attribute, branching the cases, right? And each internal node, that means before a final node, the node you get is called internal node, correspond to a test, right? And each branch correspond to a result. So you can see that in this case, this sex is a internal node, cholesterol is an internal node, and this branch is a result now, male or female, right? Then drug is there, right? Drug is my final decision node, right? Okay. So if you go further, each leaf node, that is last label of the tree, each leaf node assign a classification, whether drug A or drug B, right? So how do you decide that? That is a more important major question. How do you decide which attribute to take? So choose any attribute, calculate the significance of that particular attribute, and then split the data, and you have to repeat it for all the attributes. And how do we do that? So how do you build a decision tree, right? Okay. So for that, what we do is that, let's say we are taking cholesterol, right? And then we find out cholesterol is a bad attribute. I'll tell you how do you know that it is a bad attribute, right? So then what we do, right? We did another one. We took sex as an attribute. Is it a good attribute as a root node, or we should look something different, right? Then what happens? Basically, for any attribute, you check these qualities: more predictiveness, less impurity, and low entropy. What is the meaning of that? You can look at this. This triangular shape represent drug B and circular shape represent drug A. If the gender is female, then most of the time drug is given B. But if the male, then it can be both. Like you can see this gender is having more predictive power, right? It is less impure, right? So basically, that what we need to decide. In case of male, we go further, whether it is a high cholesterol or low cholesterol or something like that, right? So we calculate some metrics and so on and so forth before splitting it, right? Okay. So entropy, the first metric is entropy, that is the measure of randomness or uncertainty, right? Okay. So I will not go into the mathematics of it, but you can look into this. There's a formula for calculating entropy for each particular attribute, right? And then based on this entropy, we decide the root row or best splitting attribute for decision tree, right? Okay. So you can see that cholesterol, right? Okay, is here. Then gender, for gender this is a particular measurement. For male this is 0.98. For sorry, for female it is 0.98. For female it is a 0.5, right? Okay. Okay. So this is how you go about by calculating these two metrics. And then finally you see which is the best attribute, right? So you repeat it, right? Until unless you get another information, that is called information gain, right? So what is information gain? This is another matrix that you need to do. That is information that can increase the level of certainty after splitting, right? So you can see that cholesterol is very good, right? Okay. And finally, again, there is a formula for information gain. So what happens exactly? Let me skip it because it is a very 2 hours lecture that I deliver in a regular class, right? Okay. So basically, what you can do with this is that you can with decision tree you can make a decision, right? Okay. It can use for, it is called card classification tree as well as regression. You can do both kind of tasks. So let me show you a hands-on example itself, right? Okay. Okay. Let me show you that here in a Jupyter notebook first. Right? If I have some examples on decision tree, let me check it out. Okay, I'll share this. Or yeah, middle is not considered because in that case you can directly take decision, right? Okay. 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 Perfect. So I may not have the exact. Let me just give me a minute. Okay. Just give me a minute. Okay, fine. Okay, so I think I do not have an example on this particular data set, but I can show you the decision tree. It's a again, very simple. Let me share my screen and there it is. So I'm taking the same example. What I'm trying to do here is like I have a position and salary, right? Okay, let me share with you this data as well. If I can show you this data. Just give me a minute. Okay. Position. Okay, 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 okay. Okay, okay. I think I do not have the CSV file right now, but probably I can show you here itself, right? So I'm sure my screen is visible to you, right? Okay, okay. So what I'm trying to do here is that if you look at this, right? I'm just importing the library, or let me just insert here uh, 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 a cell, right? I'm reading this data. This is a position salary data, right? Okay, so what if I do is here comment, and what if I show you a data set? Okay. What is this data is all about? Okay, okay, okay. And get this cell up. This data set. I'll put this here. Here we go. So you can see that basically in my data set, I have a position label and accordingly there is a salary, right? So if you are a business analyst, this is your salary. If you are CEO, this is your salary, blah, 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 right? And what I'm trying to do here is that I'm trying to apply decision tree for regression problem, right? So again, I have an independent variable, right? And then I have a dependent variable, okay? So if I go here, right, okay, okay, so you can see in X, there is a label, right? And in Y, there is a salary, okay? So again, I'm doing the same thing. I'm trying to, split the data set in train and test, right? Okay. And finally, I'm applying, this is, takeaway is here is this decision tree, right? I'm using decision tree as a regression. You can use decision tree as a classification problem, as a regression, right? Okay. So I'm using decision tree here, right? Okay. I have created a regressor. I have, passed the arguments, whatever required. Here I'm training a model, right? And then I'm trying to predict the salary based on the level of the employees, at which level particularly is, right? Okay, so you can see here the higher the position level, the higher the salary, right? So this is a graph, very much self-explanatory, right? That's what I want to show you here. That's it, right? So this is what all about application of decision tree into the real world. Okay, did I not share the my screen with you for decision tree, ma'am? Hello,
I
hello.
was speaking on mute. Okay, am I audible?
Yeah, is my screen was visible for decision tree?
Yes, your screen was visible.
Perfect, perfect. So I think now we are done and we have good 15 minutes of time for the Q&A. Thank you.
Okay, guys, we are open for Q&A. Let us know your questions so that we can unmute you and sir can directly answer your query.
Okay, okay, book. Okay, perfect. So I got a book. Trust me, I'm not sure how we do buy books, but hardly few people read it. But apart from the book, I'll tell you something really interesting, right? Okay. So very first thing is that if you are a beginner, right? If you are a beginner and I told you, yeah, website, yeah, that's great. If I told you, right, you should not be, driven by the jargons, the big things. Oh, I do not know TensorFlow. Oh, I don't know PyTorch. I don't know GPT-3. Not at all. Make your fundamental strongs, right? This is a website. I am really a big fan of this particular website. I put into the chat box. That is math is fun. You can literally, sorry, I need to drink water. Literally, you can learn everything from here. Whether it is a basic statistics about the data, probability, math is a fun, awesome website. Awesome, right? You go, you learn it, you try to understand the basic things, right? Okay, okay, confounding variables, probably I need to think of like what can affect independent and dependent variable. Okay, okay, I mean, I need to think of, okay, maybe, okay, let me think. Meanwhile, I can answer other question. So regarding the website, I told you that Math is Fun is one of the website where you can learn basic fundamentals about maths, statistics and all. Then I will ask you to go for some basic courses in stats, right? Okay, from anywhere. You can go MIT OCW. Okay, okay. But one thing I'll tell you, everyone. Okay, now books also I forgot to tell you, right? Okay, books. More importantly, the concept you need to know about. The use cases. Let me just give me a minute. Yes. Yes. Okay. So yes. Okay. So sir, we also launch a course together. Okay, we will also launch a course together. You can mention. Okay, so we will be also having course on Amazon.
Hello. Guys, are you able to listen to me? I think there is some technical problem at sir's end. Let me try fix it. Okay, let me check. Okay, sir, I've unmuted you.
Right, right, right. I can hear you. Right. So I was talking about the books, of course, not about the academic books that you already know everything. I will share some URLs with ma'am, and she can share it later on. Right. But some of the very, very important book that I want to share with you is that is this one. Right. Okay. And this, you should read a lot, especially if you are aspiring for a data science, right? Okay, this book I do have, you can see in myself as well, right? This book name is Factfulness, right? Okay, Factfulness, okay, and this is by a very famous author called Hans Rosling. He is the one who created bubble chart, right? He is the one who created bubble chart, invented, and he is a doctor. Can you believe it? Right? He's not coming from computer science background, not from a statistician, right? And his whole family is running this particular organization, Gapminder, right? So it is a very inspiring book. Everyone in data science, whether you are in class 8, 9, or you are a 15-year experienced professional, you should read this book. This is my favorite. I do have this book. Okay, and it's a very cheaper also on Amazon and in a hardbound. So that is a one book that you can read about. You will get to know idea about the world, how world is being driven by data, right? And then another book, I'm sure most of you might have read it, but another book is that let me just call it. Uh, yes. So this is another book that is by. Okay, just give me a minute. Yes. Okay. So here. Yes. So this is another book called uh, Outliers by Malcolm Gladwell. Very, very much read into the industry by all the professionals, right? It is Outliers by Malcolm Gladwell, right? Okay, okay, Gladwell. So you will, I'm sure if you are aspiring for data scientist, that means you have a specs and you want to study a lot, right? Probably you are like me who buy more books than clothes, right? Okay, okay. So these two books will definitely take you different places in the world, right? Of the data sciences, right? What is the future scope for data science? In the foreseeable future, I see a very good future. That is why I'm going to pursue my PhD in the data science. Otherwise, I could have pursued PhD in core computer science, like a compiler design or maybe networking, something like that. But I opted for data science, right? So I think there is a very good future. I cannot be wrong now. Sorry, just making myself right. So there is, I mean, you know that, right? Despite getting admission into the CSE, Triple IT, all that blah blah, I left that. I wanted to pursue data sciences. So you can take risk with me. You can be a good correlation with me, right? Yeah. So does Tableau make difference? See, there are two set of people. I told you yesterday, now or not everyone is going to be a data scientist. There are certain people, they want, like people in the MBA, they are very good with stats, they are very good with understanding of business, but they can't code. That doesn't mean they should not be able to apply machine learning. So there are drag and drop tool like Tableau, like ClickSense. There's n number of tools. So yes, knowing the tools helps you, right? Okay, you can learn Tableau for sure, right? It makes a difference. Okay, so what is the
So,
difference
sir,
between computer engineering and computer science? I don't know. Nobody knows, in fact. Yeah,
so I was
yeah.
saying maybe I will read the questions to you because a lot of questions are missing in
Sure,
between.
sure, sure,
Okay.
sure.
Okay. So
Uh,
there is a question from Upasna. Okay, Upasna, should I
mm.
unmute you? Let me know if unmuting you will be possible. if that is comfortable for you. Okay, and we have a question from Soumya too. Soumya, meanwhile, let me unmute you and you can ask the question. We have got the reply from Upasna also. Upasna, I'll just unmute you after Soumya. Sorry, Somnath. Okay, Somnath, I've unmuted you. You can ask your question.
Good evening, sir.
Good evening.
Sir, I have a question. Like yesterday, you have told that while considering the measures of central tendency, we should suppose our data set have a lot of outliers. Then we should consider median instead of mean.
I didn't get why you don't have so many outliers at the first. Sorry, I mean you can go ahead.
No, no. Suppose in our data set
And-
there are a lot of
yeah.
outliers, and we are
Okay.
measuring the central tendency. We should look for median, not mean. So
Okay.
now, suppose in case of predictive modeling, suppose in our data set there are a lot of outliers, and these outliers are somewhat affecting our modeling. In
Right.
that case, suppose there are a lot of available models are there, like suppose regression. If we can do regression, we can do decision tree, we can do random forest, we can do
Right.
support vector machine. In that kind of thing, if there are a lot of outliers in a data set, what kind of model we should choose?
Okay. Okay, perfect. So very first thing is that if there's a lot of outliers that I need to be really worried about, right? Can't we make it journal now? I mean, it is my opinion. Again, it is a disclaimer, right? Okay. So the very first outlier can be one or two, or it cannot be so many, right? If at all it is, then you have to look. When we talk about the algorithm, you know why we have so many algorithms in computer science? Every researchers day in day out putting algorithms, because every algorithm is having some limitation. So you have to look that I haven't figured it out, but since you need to do it, so you need to figure it out. What is the best algorithm or best modeling approach that is suitable when we have lots of outlier in data, right? Probably you need to
Right.
look for that, right? Because one algorithm cannot do everything. We do not have any magical penicillin kind of medicine which can help us in all disease, right? So hit and
Right.
trial. Yeah.
Right.
Okay, sir. I'll
Thank you,
unmute
sir.
Upasna now. Upasna, I've unmuted you.
Yeah, thank you. There was this Python sheet which was displayed for an example of linear regression. I could not get it right. I have a theoretical knowledge about linear regression, but I have no idea about how it is done on a database or I mean on any kind of software. So this
Right.
was just displayed, and there was this array, and then you have just solved it. So it would be nice if you can share a video or a link or something. How do we go about it? Like, because I have no
Uh,
clue.
Okay, but definitely, right? Okay, so to be very honest, whatever I have displayed you in a regular classroom, I took 2 hours lecture for that, right? Okay, 2 hours dedicated for just for one particular concept. Sometimes even I do not complete that on that particular day because there's a lot of query from the other end, and we do not move that, right? So what I'll suggest you, since you already have a bit of theoretical knowledge, you little bit explore. There are tons of things available. Very fundamental things are available on the internet, especially for all of you, right? Those all aspiring for data analyst or data scientist. There are certain blocks that you should follow, like analytics vidya. You just write analytics vidya simple linear regression, you will find wonderful tutorial, right? Okay. And then towards data science, there are many more are there. It is just, I must say, self learning is difficult, but it is one of the beautiful things that you can do yourself. At a time you may not get it, you get frustrated, probably then a teacher come into picture, right, where you can ask help, right? So I'll say you can do that. You can go ahead. Definitely, we will be sharing that IPython notebook. I do not have problem with that, right? We'll be sharing with that for sure. You can have a look later on.
We hope, Upasna, your question is your query is solved now. Okay, let me move forward. So we have a question from Rahul. Can you let us know what 7 to 8 algo used most in DS?
Okay, data sciences. So you already know it. You just want to know from my mouth. I have to accept it. So like decision tree, random forest, logistic regression. In industry, people do not use very high funder thing. everyone starts with a very fundamental thing, as simple like correlation, right? Chi-square. So all basic starts, right? So you know that KNN, decision tree, logistic regression, random forest, SVM. These all are the 7-8 algorithms. That's it. That's it, right? If you know the fundamentals well, yes. But you should be smart enough to devise a new algorithm for yourself if you require, right? Okay, so for example, one of the patent for my patent, I have devised my own algorithm. I have filed a patent. It is already published. It is for home automation where I'm using computer vision, for image processing and all. So getting fundamental is the key idea. Very nicely. No matter at what age you are. आपको ये ego नहीं होना चाहिए कि मेरे पास 15 year का experience है. Trust me, a class 8 guy knows better than us, right? Maybe statistics if he has spent good enough time. So go for the Math is Fun website. Learn fundamentals. Yeah, please. Next question.
So we have a question from Devashri. I'm thinking for this course. So after my BTech in CSE, what I need to do?
Okay. So, I mean, but for what? What you want to do after BTech is CSE? Do you want to continue in technical field? I don't know. I think this question feel little bit ambiguous. But if I understood, if you want to go for data sciences, probably you should go. You should get a very strong fundamentals, right? That means you should learn the probability linear. Being engineer, you know that, but passing an exam and knowing is something different. Recently, I read a meme. They said that BTech is a degree of participation until you get a job, right? So I'm sorry on that, right? Not to you, but the idea is you get your fundamental strong and then everything is done, right? Being an engineer, you already know how to problem solve, right? You passed your BTech, so go for the fundamental and then go for higher certification like TensorFlow or other things. Do a lot of projects, right? Coding is must every single day. Yeah, maybe 1 or 2 problem.
Okay, guys, the timer is also again showing on the screen. In case the meeting ends and you still have questions, you can join back. And if you are good to go, then we'll be sharing the recording of this session along with yesterday's session, the slides that sir has used for your reference, for future reference. Since the timer is on the screen, I'm sure the meeting will end in a minute. In case you have questions, you are please more than welcome to join back again. Meanwhile, I'll read out the question from Ravi. R or Python, which is good to start with, sir?
Okay, so it is a very big debate, but I trust me. It is said that if you know Python, learn R, and if you know R, then learn Python. So to start with, you need to you can start with a Python. That will be easier one, right? Sean in this participant, he's the youngest one. He's having his own YouTube channel in class 8 of Python. So probably you can have a look. Sean is there. He may be. Yeah.
Yes, Sean, I think is there.
Yeah. So for I think if before meeting gets end, you can simply search my name on a Google